Hello, this is Mr. Stansbury. I'm going to take you through the notes on operations with functions. At the end of this, you should be able to say I can combine functions using arithmetic operations, and I can build functions that model real-world scenarios. Okay, so first things first, there's a bunch of different functions that we can, function operations that we can do. If you have f of x plus g of x, that's the same thing as f plus g of x. F of x minus g of x, f minus g of x. F times g of x is f of x times g of x. F of x over g of x is f divided by g of x. Hopefully that's, I'm sure people are looking at this going, what the heck does this even mean? Because we're going to look at some more function stuff here in a second here, but there's ways of combining these things together with a little bit different notation. So let's take a look at some examples, and this should help make a lot more sense. Okay, so we've got f of x is x minus 3, g of x is 3x plus 1, and h of x is x squared minus 5x plus 6. Find each function. Okay, so we have f plus g of x. So what the thing said on the previous page is that's going to be f of x plus g of x. Okay, f of x we know is x minus 3, and then g of x is 3x plus 1. Okay, so officially it looks like that. We're just adding them together, so really it's just, we'll take the x plus the 3x is 4x, negative 3 and positive 1 is negative 2, and that's what f plus g of x looks like. So you're just adding the two functions together. Okay, for b, we've got basically h minus f of x is h of x minus f of x. So we take h of x, which is x squared minus 5x plus 6, and we're going to subtract f of x, which is this x minus 3. Okay, so this is why it's important to put these, like when you substitute them in, put them in parentheses, because this whole x minus 3 is getting subtracted, so we got to distribute that negative to both parts here. So we just end up with x squared minus 5x plus 6, and then negative times x is negative x, negative times negative 3 is positive 3. Now we collect like terms. X squared, let's see, we've got negative 5x, and negative x is negative 6x. So those are gone, and then 6 plus 3 gives us 9. So that's what h minus f of x will equal. Okay, g of x, g times f of x is g of x times f of x. So we've got g of x, which is 3x plus 1, times f of x, which is x minus 3. Okay, and then remember, back to good old algebra, this is where you got to foil this thing out, right? So multiply it all together. 3x times x, if we do FOIL. If you don't like doing that, there's other ways to do it too, but we'll just stick with this for now. 3x times x is 3x squared. Outside 3x times negative 3 is negative 9x. I for inside, 1 times x is x. And then last, 1 times negative 3 is negative 3. We combine our like terms to get 3x squared. Negative 9x plus x is negative 8x plus 3. Okay? Now, for those of you that are FOIL haters, another way that we could do this is I call the stack method. I stack one on top of the other. So I'll take, say, 3x plus 1 and put it over x minus 3. And then we just multiply it like a 2-digit by 2-digit multiplication. Negative 3 times 1 is negative 3. Negative 3 times 3x is negative 9x. We usually leave a 0 in here to hold the place, because x times 1 is 1x. Right? We'll line that right up with the other x. And then x times 3x is 3x squared. And everything's all lined up for us nicely. So that's negative 3, negative 9x, and 1x is 8x. And then we also have 3x squared. And note that these two are the exact same thing. So either one of those ways, whatever floats your boat. Okay, and then part D, h divided by f of x. So that's going to be h of x over f of x. So in this case, h of x is x squared, minus 5x plus 6, and f of x is x minus 3. Okay. Now, what we can actually do on this top part here is we can actually factor this out and see if it simplifies with the bottom. Okay. So first off, we already know that x cannot equal 3, right? Because if you have 3 minus 3, that ends up giving you 0, and we can't divide by 0. So we know for sure x cannot equal 3, but let's figure out what else this simplifies to. So if we try to factor that top piece, a little kind of trick here is chances are, well, really it's not going to matter unless it's got an x minus 3 in there. So let's just see if we have an x minus 3 as a factor. So I'm just going to put that in right off the bat. X times x will give us x squared. And negative 3 times what gives me positive 6? Negative times a negative gives me a positive, and 3 times 2 gives me 6. So we'll double check to make sure that this works. We could have just factored it out to get this, but I'm just kind of showing you a little bit of a possibly an easier way to figure some of these more difficult ones out. But anyway, x times negative 3 is negative 3x, and negative 2 times x is negative 2x. That adds up to give us negative 5x. So that means that these are the factors, because x times x is x squared, and negative 2 times negative 3 is positive 6. So now that we have that, these two cancel out, and we're just left with x minus 2 as our answer, but also where x cannot equal 3 would be our full answer on that. Because in the original up here, we could not have x to equal 3. Otherwise, that would, again, we'd be dividing by 0. Okay? Okay. One big set of one last example to look at. But before we do that, let's take a quick comedy break.
Who's coming up with serving sizes? The serving size of ice cream is a half a cup. What is that? Is that like a joke some guy put on there? Hey, come here. Look what I put for the serving size. I just did it as a joke, but they're going out like that. I don't know what to do. Just let it go. I guess there's nothing you can do now. You ever know anybody that eat a half a cup of ice cream? Hey, you want to go grab something to eat? Oh, no. I had a half a cup of ice cream. Yeah, a whole half a cup. I just kept eating and eating and eating. I must have had 2 spoonfuls. I think a serving size of ice cream is when you hear the spoon hit the bottom of the container. Right? When you can't do this anymore. I even ripped the side. Not sure what they're talking about for that. Half a cup of ice cream.
All right. This one here, we've got Bucky has been asked to submit a bid for installing garden gnomes in Mr. O'Malley's backyard. In the bid, he needs to include the number of gnomes he can artistically install in a 4-hour session, the cost per gnome, including installation, and the total cost of his services for a 4-hour session. Okay, so write a function g of h to represent the number of gnomes Bucky can install in a 4-hour session. When it takes him h hours to install one gnome. So what we've got here then is g of h is going to equal, now let's see, he's going to do a 4-hour session, and then what we need to do is multiply that by what his rate of installation is. So if it takes him h hours to install one gnome, we wouldn't want to necessarily multiply that by h. Like if it takes him 2 hours to install a gnome, he's only going to get 2 gnomes in. So if we did times h, that'd be 4 times 2 tells us that it's 8. And we know that that's not true. So what we always do on this is we put 1 over h. Okay, so let's say if it took him 2 hours to install one gnome, that's 4 times 1 over 2. 4 times a half is 2. So then that would say that it actually takes, if it's going to take him 2 hours to install each gnome, he's got 4 hours total, that's going to give us 2. So this is probably one of the trickiest parts about that is the coming up with the rate And like this is, it's always going to be your 1 over, however, well, almost always going to be your 1 divided by however long it takes to install a GNOME or whatever you're installing. Okay, so that's going to be the tricky part, but we've got that. What are the restrictions for the domain? So H, domain is what the H can be, right? So this is hours. So hours has to be greater than or equal to 0, right? Because we can't have negative time, but we actually can't actually make it equal to 0, because if we did, that would be dividing by 0. So it's going to be just the hours have to be greater than 0. Okay? So that's the restrictions for the domain. That's what they're asking. It's like, what can the domain be? And that's our H. Okay, the G is going to be our Y, our range, and H is going to be the domain. Okay. Part C, Bucky charges $30 for each garden gnome and $95 per hour for installation. Write a function C of H to represent the amount Bucky will charge for a gnome that takes H hours to install. Okay, so our cost per hour, is going to equal, he's got makes $95 per hour plus $30 just for like getting out there, plus 30. So that's going to be his cost. So this is his cost function. Use the total cost of Bucky's services using G of H and C of H to find G times C of H, because this is how long it's going to take for each gnome, and like that's going to be the hours that he's going to spend. So we can use that and multiply it by this to actually figure out what the total cost is, instead of first figuring out the hours it's going to take and then plugging that hours in to find the total cost. We're going to actually combine these together. So G times C of H, so G of H times C of H. So G of H we already came up with is 4 times 1 over H. And then our C of H is 95H plus 30. And we got to make sure we put parentheses around that, so we multiply both sides there. So really, let's turn this 4 times 1 over H. Let's turn that into 4 over H, because that's 4 times 1 is just 4, so that'll make it a little bit easier. So we're going to do 4 over H times 95H. So let's do this. 4 over H times 95H plus 4 over H times 30. Okay, so on this first one here, the H's are going to cancel out, so we just have 4 times 95. We bring up our calculator. 4 times 95 gives 380. So that's 380. Plus, now we have 4 times 30 over H. So that's 120 over H. Okay, and that's going to be our G times C of H. Okay. So this is our function. This is going to be our G times C of H. Now it says Bucky estimates it's going to take 15 minutes. I drew over the top of that. It's 15 minutes to perfectly place each gnome. How many gnomes can he perfectly place in a 4-hour session? Okay, so if he's going to 15 minutes, that's 4 per hour times 4 gives us that he can do 16 per session, right? Part F, what is the cost per gnome including placement? So the cost per gnome, we'll want to plug into the C of H here. So that's going to be cost, and we know that it takes a quarter of an hour to place every gnome, equals 95 times 1/4 plus 30. So remember, the 30 again is the cost of the garden gnome, and this is going to be like the hourly wage, but it only takes a quarter of an hour to place one. So that will give us, let's see, we've got 95 times a quarter, which is basically divided by 4, plus 30, gives us 53.75 for the cost of the gnome, and let's see, per gnome. So cost of the gnome and for placing it. Okay, and then what would be the total cost if Bucky worked for 4 hours? Okay, so if he works 4 hours, he can get in 16 gnomes, right? So we could do 16 times 53.75, right? So we could do that. And let's get this here. So times 16 gives us $860 for 4 hours. And if it was 3 hours, let's see, 3 times, he places 4 every hour, so 3 times 4 gives us 12, so that would be 12 times 53.75, which would give us, that's money there, so let's see, 12 times 53.75 gives us 645. Okay, and that's for the 4 hours and the 3 hours. Okay, that's all we have for operations with functions. If you have any further questions, please feel free to ask.